היי, אני ענבר מהמעבדה של מישל פורטמן. הכותרת של ההצגה שלי היום היא Predictive Policing in Illegal Fishing Context. במעבדה של מישל אנחנו עוסקים בין השאר בתכנון מרחבי ימי, שזה תהליך תכנוני שכולל הקצאה של מרחבים בים לפעולות ושימושי אדם, במטרה להימנע מקונפליקטים בין שימושים ולשמור על הסביבה. ובחלק הזה של המחקר שלי, שאני אציג בפניכם היום, אני מתרכזת בנושא שמירה על הסביבה ודייג. הדוקטורט שלי כולו עוסק בטכנולוגיות גיאו-מרחביות, שמאפשרות איסוף וניתוח של מידע על הסביבה הימית, טכנולוגיות כמו מעקב אחרי ספינות מלוויינים, איסוף מידע על תנאי הים מהחלל. ולפני שאני אתחיל, אני רק רוצה להציע לכם להעביר את הוידאו עם הפנים שלי לצד שמאל למטה, כי אז זה פחות יציג לכם את המצגת, אם אתם משתמשים בספיקר ויו. וגם סליחה, כי אני הולכת לעבור על האנגלית, כי זה פשוט יותר נוח לי עם המושגים המקצועיים.
אוקיי.
אוקיי, מעולה. Okay, my presentation outline. So we're going to talk about the need for sustainable fisheries and the international efforts taken to promote sustainable fisheries. I'm going to talk to you about illegal, unreported, and unregulated fishing, which I'm going to call for short illegal fishing, and how our fishery restricted areas are supposed to help with illegal fishing, and what are the challenges of enforcing those restricted areas. I'm going to tell you about my research aims and the methods taken, and a quick summary because I don't have my final results yet. So, Fisheries is a provisioning service that we get for free from nature. It provides us with food and gives us income and employment. The problem is that if fisheries continue acting in an unsustainable way, meaning depleting the natural resources, we risk this exceptional ecosystem service. So in terms of international efforts to develop and maintain sustainable fishing, I want to refer you to the UN Sustainable Development Goals. In 2015, all UN countries signed this 2030 agenda of the global goals, including, for example, eradicating poverty and hunger. And out of the 17 goals, I want to talk to you about goal number 14 because it deals with sustainable fisheries. It goes like this: conserve and sustainably use the oceans, seas, and marine resources for sustainable development. And more specifically, goal 14.4 is eliminating overfishing, as well as illegal, unreported, and unregulated fishing. And the reason that UN countries acknowledge illegal fisheries is because it threatens the ocean food production. Since the world population is growing, there is more demand for ocean-sourced proteins. Now, ocean food production is threatened by overfishing and habitat destruction. And illegal fishing causes overfishing and habitat destruction. Illegal fishing is an economic, ecological, and a social threat. It causes an estimated $10 to $23 billion losses every year. It accounts for 20 to even 50% of all fish catch in some regions. And this industry often uses destructive fishing practices, like the destruction of habitats and fishing where fish reproduce. And it uses deceptive practices to reap profits at the expense of small-scale local fisheries. So there is growing evidence that when fisheries are properly managed with strong action from fishery management and governments, stocks are consistently above target levels or rebuilding. However, in some countries and regions where fishery management is not in place or it's ineffective, the status of fish stocks is poor and deteriorating. So that brings me to our area, the Mediterranean. The General Fisheries Commission for the Mediterranean is a regional fishery management organization, and it's in charge of the management of marine living sources and on gathering information about the progress in achieving the UN goals. And it turns out that illegal fishing causes the most harm to bottom living fish. And it's very common to fish trolling nets on the ground. And for those of you who've never seen what bottom fishing looks like or why is it destructive to habitats, I have this short video. Just let me know if it plays well.
כן, רואים.
A bottom trawl is a type of fishing net that's pulled along the sea floor. Fishermen commonly use bottom trawls to catch shrimp and bottom-dwelling fish like halibut and sole. In addition to these target fish, however, the nets also catch a variety of ocean life that's usually thrown back dead or dying. Dragging heavy gear across the seabed can also damage sensitive seafloor habitat. Reducing the harmful effects of bottom trawling requires either modifying the fishing gear or limiting the areas where trawling is allowed to protect sensitive bottom-dwelling organisms and their habits.
Okay, so as you've heard in the movie, one of the ways to protect from harm is just to limit the areas that are allowed to be bottom trawled. And the General Fisheries Commission created this fishery restricted areas for bottom fishing. So on the map here of the Mediterranean, in orange, what you see is the area that it has a ban for fishing on the bottom that is deeper than 1,000 meters. And that's mostly because no one knows what's down there, like more of a precautionary act. And on the other areas that are smaller, that are shallower than 1,000 meters, they ban fishing in specific zones that they know have an economic or an ecological importance. And those are the much smaller areas in green and blue that you see here. And they protect an essential fish habitat or a vulnerable marine ecosystem. So this is an example of what it looks like, this habitat I keep talking about that are being destroyed by bottom fishing. And for example, you see deep water coral reefs, and they're important because they elevate biodiversity and biomass in the habitat. And some areas provide shelter or are a spawning and nursery area for a variety of species. And the ban on bottom fishing, where fish, for example, reproduce, and the protection of their offspring nursery grounds is one of the ways to ensure the renewal of commercially fished species. Now, the problem is that even these smaller green and blue restricted areas are fished with bottom trawlers. So as you can see here, bottom fishing is very destructive. It's the same areas that you see on the right and on the left before and after they were trawled. And in the map here, in the light blue rectangle, I marked a fishery restricted area around Italy. And the colors are fishing hours. So purple is the least amount and orange and yellow is the highest fishing effort. And what you can see is that inside the light blue rectangle, it seems almost highlighted from all the fishing that is down there. That's 14,000 hours in front of Italy in the years of 2018. So the reasons for under optimal enforcement are that some fishery restricted areas are large or they're remote from shore, and enforcement agencies, they're just under budgeted or understaffed. And the 1,000 of illegal fishing hours in the Mediterranean is discovered when analyzed in retrospect. The problem of discovering all the illegal fishing in retrospect is that violators need to be caught in the act to be prosecuted. So what I thought is to use predictive policing, meaning using data on past crimes to predict where and when the next crime is more likely to happen. And this is something that is done by the police on land to focus patrols. So my research aim is to help enforcement officers focus patrol efforts while saving money, manpower, and catching violators in the act. And I'm going to attempt to use only publicly available data to create and update my model's forecast of when and where illegal fishing is more likely to occur. So this model can be more affordable to its potential end users. And my formal research question is this. Assuming that modeling human behavior based on past fishing behavior predicts future behavior, what is the best combination of publicly available database factors to use for prediction? So I'm using data on fisheries fishing location based on AIS, which is this anti-collision automatic identification system on board of the vessels. And it gives me information on where the bottom fishing vessels fished. And I use relay AIS data to teach the model to predict future location choices based on explanatory variables. And for these explanatory variables, I performed a literature review to collect data on parameters affecting fishermen's decision on where to fish. For example, do they look at ocean conditions, the gas price, the fish market price? And I'm going to cross each fishing event, so date and location, with possible predictive parameters to find the combination of factors which explain best a fisherman's location choice. And that combination is what's going to be used to predict future fishing locations.
עוד דקה, ענבר.
עוד דקה? יש לי 2 שקופיות. So I'm using this model. It's called random utility model. It assumes that each person picks whatever alternative that is best for them to maximize their utility, their benefit. And it also assumes that reasons for choosing one alternative over the other, well, they could be partially known and partially unknown, random, because we're people and you can never guess everything a person is thinking, but this model can handle some unknowns. And random utility models are used successfully in fishery research for over 30 years for estimating fishers' response to fishery area closures to predict the consequent displacement of fishing effort. So if we choose to close this area, where will the fishers go? Now here, I use this model to see what happens if the effort is not displaced outside the restricted area. Like you saw in the Italian case, if they do go inside. Now, I believe the output of the model could look like a heat map of where fishers are more likely to be. Like you see here in the figure, it's a map with longitude and latitude lines, and the colors show probability. Where is it most likely fishers will fish? So last slide. I've not run the model yet because it takes a long time to sort through all of the data for the model. I did finish the literature search on the predictive variables. And the ones I chose are economic. So I'm going to use fuel price to represent the trip costs and fish market price to represent the revenue of the trip. And then there's tradition. So it turns out habits and seasonality are very common drivers of fishing behavior, like where they're used to fish at that time of the year. Unless we have compliance. So compliance drivers such as enforcement level of the restricted area, how high is the fine, basically what is the risk of being caught. And this is something that, as far as I know, have never been used before in random utility models as explanatory variables, probably because they haven't been used to explore spatial non-compliance, meaning if fishers do go in to fish. So just to sum up, I'm going to use past fishing events to predict future fishing events. I want to understand what factors drive fishers to fish inside restricted areas and use that to predict when and where they are more likely to do so again. So patrol enforcement efforts could be more focused and deter the violators or catch them in the act for prosecution. That's it. תודה.
תודה רבה ענבר. ואנחנו נעבור לפרופסור דן ליברזון. דן, אתה מוכן?
לא שואלים את ענבר שאלות?
יש שאלות?
הצעות גם התקבלו בברכה.
אני יכול לשאול שאלה? אם כבר...
בוודאי.
ענבר, הייתה מצגת ממש מעניינת. את יכולה טיפה להרחיב על המודל עצמו? כי רק אמרת השם שלו.
כן.
אפשר טיפה פרטים אם זה מודל... אני לא הבנתי אם זה מודל אינטליגנציה מלאכותית או מודל מסוג אחר.
זה נקרא discrete choice model, אז כל נתון מתייחסים אליו בפני עצמו. מה שבעצם אני עושה זה שיש לי, תדמיין טבלה לצורך העניין, יש לי בשורה אחת את קוד הזיהוי האמיתי של כל ספינה, בכל יום ויום בשנה. אחר כך כתוב לי באיזה ציוד דייג היא השתמשה, באותה נקודה שהיא דגה בה קו רוחב וקו אורך. יש לי עוד נתונים שאני משיגה על הספינות מבחינת הגודל מנוע שלהם וכדומה, דברים שעוזרים לי להבין צריכת דלק. ואחר כך, על כל אירוע דייג כזה, אני הולכת להוסיף את הפרמטרים שהוספתי, זאת אומרת, מה היה מזג אוויר באותו יום, מה העומק שהם בו דגו, מה היה מרחק מהחוף, ואני הולכת לעבוד, לסנן את המידע הזה אחרי שאני אזרוק אותו על מפה, אני הולכת לסנן רק את האזורים שראיתם בירוק וכחול, שזה האזורים שהם הקטנים יותר, שהם אסורים לדייג, בגלל שיש להם איזושהי חשיבות אקולוגית או לדגים, ורק על הדאטה הזה אני הולכת להסתכל, מכיוון שאני יכולת לקחת את המידע, חלק מהמידע העבר, נגיד יש לי 4 שנים של דייג, אז אני יכולת לקחת חלק ממנו, להריץ אותו ולראות מה הפרמטרים, הקומבינציה של הפרמטרים שהכי מסבירה הכי טוב, כמו שעושים ברגרשן, רואים איזה קומבינציה של פרמטרים מסבירה הכי טוב למה קרה מה שקרה, ואז אני הולכת לבחון את זה על חלק מהדאטה שלא השתמשתי בו. בעצם לראות אם זה באמת, מה האחוזים שזה מסביר מלמה מישהו היה איפה שהוא היה.
למעשה השאלה שלי הייתה על החלק האחרון, איך נעשית המעין הרגרסיה הזאת, זאת אומרת, איך המודל עובד, אבל בסדר, אוקיי, אני יכול להסתכל בסיפור.
כן, לוג'ית, מאוד טוב.
אוקיי, תודה.
תודה, ענבר.